So first, a remark. Number one, if a row has a leading one in the right-hand side column, then remember the example actually before our long calculation.
No solution.
Then it means no solution. So if the leading one is totally on the right in your augmented matrix, then it means no solution. No? Number two, what happens if a row is totally zero? There's just zeros everywhere. What can we say about these rows if this ever happens? Sorry. Rows which are entirely zero.
They should be on the bottom.
They are on the bottom, but let's say if you like to solve your linear equation system, what can you do with these rows? Do you have to consider them at all?
No, they're not useful to
Yeah,
solving.
they actually don't contain any information. So rows which are entirely zero, you can be discarded. They don't change our solution, no? Can be discarded. So we don't need to consider them. And the other one is more remark. Sometimes later on when we talk about the outcome of a Gauss algorithm, remember we have always leading ones and they are staggered. They can be anywhere in the matrix, always moving to the right. Sometimes for simplification purposes, when I like to make a picture for it, I assume that the leading ones are all in the front. Yeah. So sometimes I assume that all leading ones are in front. This essentially means you switch columns, yeah, which we usually don't do, but just to make a picture, it's actually nicer. Then also based on what we just did, we actually have two nice results already, even we have not done much until now. So if you have a homogeneous system, can someone tell me what was again a homogeneous system?
It has all zeros on the right side.
Right-hand
Yes.
side.
So in my example here, sorry, it would mean here everything here is zero, no? And even if you add rows or multiply, if it's zero at the beginning, it stays zero. So it can never change. A homogeneous system with n variables and r leading ones has how many parameters?
N minus R?
N minus R, because for every variable which is not a leading one, you have a parameter. And so there are leading ones, so there are N minus R parameters. So that also means it has infinitely many solutions, no? If N and R, also if R is smaller than N. And then similar to this, and that's, I promise, is really the last one, and then we are done. And it's again about a homogeneous system, which are always kind of easier. With n variables and m smaller than n rows has how many solutions? When you think about this, so you have n variables, imagine n is 3, and only m rows, but m is smaller than n. So let's say 3 variables and 2 equations.
So it would only be one, or no solutions, right?
Again?
I'm sorry, never mind.
No, think about how many leading ones can there be at most.
There can only be 2 leading ones.
At
right?
most, no? Maybe
Yeah.
only one leading one, no?
Maybe only one, yeah.
So that means R is guaranteed smaller than N. So N minus R is positive. So if you have a homogeneous system with N variables and M rows, it has guaranteed at least one parameter. So it has infinitely many solutions. Because the maximum number of leading ones is M, the number of rows, because every row can only have one leading one. And that means there are for sure some parameters left. So if someone has a homogeneous system, 2 by 3, you know for sure there are infinitely many solutions, even without doing any calculation. So this is actually kind of nice to know already, and it shows you a little bit, just by using Gauss algorithm, you understand already a little bit better what can actually happen in linear equation systems. I mean, that's what this class is about. It's not just solving them, a small example, it's really understanding what can actually happen. And these are actually our first 2 results in this direction. Okay, I assigned already some homework for section 1.2. I think by 11:15 or later on, it will show up on Wiley Plus. So let's make, if there's no more question about this, I would like to make then about 10 minutes break. So like by 10:21, I continue, and then we start section 1.3, but I think 1.3 I will not be able to finish today. So maybe 1.2 is the only homework you get later on today. Is it okay we stop for a break? Anyone?
Yeah, that's
No,
fine.
thank you.
Yes.
Okay.
Need coffee.
Then I just stop a little bit the recording, and I start again by around 10:22 or so.
Okay, sweet.